Okay, this is lesson 18. We're going to start as usual, going to the GitHub page and click on lessons, go down to lesson 18. And so this lesson is on interactive visualization with Bouquet. So this is a interactive visualization library that generates an interactive plot that's basically an HTML page, a web page that you can then make dynamic graphics that you can zoom in, zoom out, scroll around, do kind of all kinds of cool things that just aren't possible with a static plot. And this is a great way to explore data, and also you can share it with other people, maybe as a supplement to a scientific paper or a web page that you want to make some data set that's more interactive. This provides an interface to generate those plots that's fairly straightforward. So we're going to click on this raw link here. This is working now, thankfully, so we can copy that URL, open up the terminal, go to SIO 209 lessons, curl-o, type that URL, download it, and then we're going to source activate Python 3. And finally, we can open up Jupyter Notebook. Scroll down, open up lesson 18. Okay, everybody following along? Great. So yeah, there's some introductory information at the top here from the Bouquet homepage, which is linked here. There's also a link to a user guide and a more complete API reference at this reference guide link. There's also a gallery and a notebook viewer gallery. So there's a lot of different resources that are linked here. But you can find these all from the Bouquet homepage. So before we get started, there's two packages we're going to need to install. One is Bouquet itself, and another one is called Pandas Data Reader, which we're going to use to download some stock data for one of the examples. So we're going to go back to our terminal, open up a new tab. We're going to activate that environment in this new tab. And then we can type conda install Bouquet. And hit enter. I've already got it installed, so I shouldn't have to do anything. So yeah, mine's already installed, but if you're doing this for the first time, you should go through and install everything. Is that working for people? Okay. And then next we want to install the Pandas Data Reader. So you can kind of see through my terminal what the command is. So it's pip install pandas data reader. And mine says requirement already satisfied, but go ahead and follow the prompts for that to install that. Everybody good on those? Okay. So let's go back here. Okay, so we've installed those. And as a basic sort of introduction, there's two sort of interfaces for Bouquet. There's one called Bouquet.models, which is a more low-level interface that gives you more flexibility. If you're doing some development or you want more control over building your interactive visualizations, you can use this interface. But if you just want to do something quickly and get something working quickly, you can use the Bouquet.plotting interface that is centered around composing what we call these visual glyphs. So you can kind of think of this as the difference between Matplotlib and Pandas, right? Matplotlib is more lower level, Seaborn. Matplotlib and Seaborn is more higher level, so it's kind of a wrapper or a higher level interface. You get the same things are happening under the hood, but the way that you interact with it and the amount of code you have to type is different. So first of all, we're going to do an example using the Bouquet Plotting interface. And we're going to use this object called figure, which is imported from the Bouquet Plotting module. So we're going to, from Bouquet Plotting, import figure, output file, and show. These are the three functions we need to use. So go ahead and execute that. Is that, in fact, yeah, we're good. We're good here. Okay. There's not a lot of output that actually goes to this screen in this lesson, so we don't need to clear the output. But if you do, that's fine. So that worked for everybody? Cool. So next we're going to create a figure object, create what we call some glyphs, which are like graphs, basically, and then add some customization. So first we're going to create a figure. Optionally, we can specify the width and the height, but we don't have to. We're then going to use this on the figure object itself. We're going to use this, create this circle glyph and this triangle glyph with these x and y coordinates, a certain size, and a certain color. Optionally, we can make the size a vector as well, and so we're passing different sizes to these glyphs. We can then, I'm going to create a new line here. We can then have a color for that. We can also have an alpha, so this is the transparency. So this this glyph will be a little bit, halfway transparent. We can specify a title, and the text for the title, and a color for the title. We can specify axis labels, and we can specify tick colors. Finally, we specify the output file. So this is going to be called scatterplotting.html. This is going to be located in the current directory because we're just specifying that local position. There's no other path that we're giving except for the current path. And the mode will be CDN, which stands for Content Delivery Network. This is the default setting. What this does is, I can add that in here. What this means is that when the HTML file that we generate is trying to get style sheets and various information that it's using to render, because we're going to make a web page basically, and that web page has various style files and things, cascading style sheets or CSS files. It's going to download those from the internet instead of having everything local on your computer. So it's a smaller file, but it requires you to be connected to the internet. There's another way where you can, there's actually several ways where you can adjust the mode of how this is done. including where the files are residing, but you can also make a single standalone file that has all of the information in a single file, so that it doesn't require an internet connection, and you can share it with someone else, and they don't need an internet connection or any connectivity to make it work. Finally, we're going to show that file, and it's going to pop up in another browser. So this is the file we just made. I'm going to make my screen bigger. So we have these glyphs of circles and triangles with different sizes. The triangles also have some transparency, as you can see. We have axis labels, and then you see this toolbar on the right, which right now we just have a default toolbar, but these provide a bunch of different functions. So we can we just have this bouquet logo up here at the top. This is pan, so right now we can turn that on and off. Right now it's on. So pan allows us to pan around on our plot, and you can see that the axis moves as we move, but the size of the plot stays the same. We have a box zoom, so we can highlight that tool and then zoom in on part of the plot, and again the axis labels, and if we pan, we're going to stay at that zoom level. We have a wheel zoom, so this allows us to scroll. If you're using a Mac, you're probably using your trackpad to do this, like you would on a Google Maps, for example. So that's pretty handy. Now, if we want to save this plot as an image, there's this save icon here in our toolbar. We can click on that. It's going to bring up an image file. This is a PNG image, and we can either drag and drop that, or we can go up to our browser's menu and say Save As, and it's going to bring up this Save As box, and we could just save it as my bouquet plot.png. And if we go back to our web browser here, we can see that it's been saved in our folder here, and we can open my bouquet plot, and we can see that it's decent resolution, not amazing, but it gives us a facsimile of what the plot looked like when we saved it. We can also reset the plot. So this will take us back to the original layout. So a lot of different functions here. There's also click on this help icon, and this will give us information about all these different tools and how we can configure them. Okay, so a different example here. We're going to create a different plot with some more glyphs and elements. So first we're going to have some data. We're going to use X as just this list here of floating point values, and then we're going to make 3 different Y variables using a list comprehension. So this is this would be basically x squared. This is going to be 10 to the x, and this is going to be 10 to the x squared. And we're going to specify the output file. It's going to be called log lines, and when we create the figure this time, we can actually specify the tools that we want to create. So we're going to have a pan, box zoom, reset, and save. We're going to specify a y-axis type, so this will have a log scale instead of a linear scale. We can specify the range as well. Title, x-axis label, and y-axis label. And then we have some other ways to add these glyphs. So instead of, or we have some other options. So we have a line and circle before we had a circle and a triangle. So we create those with some options and then generate the plot, or show the plot. And you can see that we have this. So in matplotlib, you can say label equals a string, and it will use those labels for the legend. In Bouquet, it uses this command called legend. Same idea though. When you plot the graph, and in fact, it doesn't require you to specify a legend. If you say legend equals this, it will add that to the legend. So same idea, we have all these options, we can reset. And you can see that the Y scale here is a log scale, and that will adjust based on the zoom level. Okay, so as I mentioned, are there any questions to this point? As I mentioned before, we can generate HTML file in different ways. So if we go to the lessons folder and we open up, I have a command called Sublime. You might have one called Atom, or you might just have to open up, somehow you want to open up this file in a text editor. Another way you can do it is do open-a applications, for example, Sublime Text. So this is what the HTML file looks like. There's a lot of information being rendered in this main part of the file. Again, this is a JSON file. This is similar to the IPython notebooks that we have. But the style sheet and JavaScript files here are residing on this content delivery network cdn.pydata.org/bouquet. So the style sheet and the JavaScript that are used to give the styles and do the rendering is all online. So that makes this a really small file. If we do a DU, which is disk usage, that file is only 24 kilobytes. So very small file. There's a question. Yes. So by default, the mode is CDN. So by default, it will use this kind of. By default, yeah. Let me go back. By default, it will add these lines, and then the only information that will be in the HTML file is basically the stuff that you specified when you created the plot. So like I want the values of the data, axis labels, those kind of things. But all the styling and all of the rendering will be online, and that's just the default setting for Bouquet. It makes for a lightweight file. But yeah, so let's just go through this. So as it says, JavaScript is the scripting language that makes possible the interaction between the elements in the browser, and the cascading style sheets controls the styling of the text and everything else. So every time you generate a graph, Bouquet is pulling the CSS and JavaScript files from the server, and this is the default option. So if you want to have those files stored locally, either with a relative path or an absolute path to where they're located, you could say mode equals relative or mode equals absolute. And if you want everything to be stored in the HTML file itself, you can do mode equals inline. So we'll try that out next. And here we're going to play with a few more options. So we're going to, I'm going to make this so it's a little more readable. You notice you get the indentation to come out right if you hit enter with the notebook. So there's a few things we're going to do. We're going to specify we don't want the Bouquet logo to be displayed, so we're going to say logo equals none. We're going to specify a few different tools this time, and we're going to specify the toolbar location to be below the plot instead of on the right, which is the default. And we're going to make, again, a couple more glyphs, and we're going to call this scattertools.html. So now we have our bars down here. We still have this pan tool. We also have this lasso select tool, which will just select the points that we highlight. It doesn't zoom in. We have the box zoom again, and the scroll zoom. And you can see that these two are compatible with each other, so that we can have both active at the same time, and then we can reset. Now, since we said that this was inline, the mode was inline, we can go back here and we can do we can open that file, scatter tools. So here is the CSS information. You can see this is a much bigger file. Here's the JavaScript. So a lot of information. And finally, down here at the end is our actual code.
How'd you get there again?
I just opened the HTML file in a text editor. So by default, if you just open the file, it will open in a web browser. So you have to say, I want to open with a text editor. So I did. If you have remember at the beginning we made some aliases. So you might have made an alias for Atom, where you just type Atom instead of having to type. When you're doing that, or when I type Sublime, I think I maybe have Atom too. Yeah. When you're doing that, it's just a shortcut for open-a and then the name of the application and then the file. So if you're using Atom, it's just, here's the same thing. So you don't want to edit the file here usually, although you can edit HTML files, but this is an automatically generated thing. If you generally don't want to touch anything here, but just to show you that. this is almost a megabyte now, 708 kilobytes compared to 24 before. So, and as you add more data and more things, it might add up. But if you're unsure about how things are going to get used, it might be better to have it all hard coded in there.